Hello and welcome to this learning video. In this learning video, we are going to discuss the third case of Fourier series expansion of f of x in the interval minus pi to pi or minus L to L, where L is any arbitrary number. Okay, and whenever you have to expand the Fourier series, whenever you have to get the Fourier series expansion of the function in the interval minus pi to pi or minus L to L, there is an involvement of even and odd function. So you know that what is even and odd function. Suppose you have a function f of x. Okay, suppose you have a function f of x, then this function is said to be even. This is said to be even if f of minus x is equal to f of x, and this is said to be odd if f of minus x is equal to minus f of x. This you know already, f of x. Now I am going to let you two very important things, like sometimes the function is given to you and you cannot predict whether the function is even function or odd function. So in such cases you have to draw the graph. Okay, so if you have a function, say f of x, and if the graph of this function in the interval, say minus pi to pi, suppose if you have a function f of x in the interval minus pi to pi, then this function is said to be even function if its graph in the interval minus pi to pi is symmetrical about y-axis. Okay, I repeat, if the graph of the given function in the given interval is symmetric about y-axis, then this function is said to be an even function. Okay, now the second thing, this function f of x in the interval, given interval, is said to be an odd function if the graph of that function is symmetrical about the origin. Symmetrical about origin, odd. Symmetrical about y-axis, even. Simple. Okay. So now let me tell you something regarding this. So as the even and odd is clear, now you just see here the Fourier series for an even function is this: f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx, where a0 is this and an is this, meaning thereby if the function is even, you just have to find out the a0 and an. In the even function, the coefficient bn is 0. Okay, and whereas in the Fourier series for odd function, we have only bn, a0 and an is 0. Okay, and we will be using this property of definite integration, that integration from minus a to a f of x dx. If the function is even, this is 2 times, and if the function is odd, it is 0. Okay, so without wasting any time, let me take an example on this topic. So the question is express the question is what is the question? Express f of x is equal to mod x in minus pi less than x less than pi as Fourier series, and deduce what you have to deduce. You have to deduce one result, and deduce that 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on is equal to pi square by 8. Okay, So let's see now. So what is given to us? We are given a function f of x. Okay, so we have, or you can write, given f of x is equal to mod of x. Okay, and you can certainly say that this function is even by, therefore f of minus x is minus of mod x, that is mod x, which is equal to f of x. So what you can say? We can say that this function is an even function. Therefore f of x is an even function. So as f of x is an even function, so bn is equal to 0. Okay, you can write here like implies bn is 0. So what would be the Fourier series? Thus the Fourier series for f of x is, means the Fourier series for an even function. So what is this? This is f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx. Simple. Now what we have to do, we just have to find out the coefficient a0 and an, where a0, what is a0? a0 is 2 by pi integration 0 to pi f of x dx. And what is an? an is 2 by pi integration 0 to pi f of x into cos nx dx. Simple. 2 by pi integration 0 to pi f of x into cos nx dx. So let us find out a0 and an. Okay, so I am finding a0 over here only. So this is 2 by pi in the interval 0 to 2 pi, in the interval 0 to pi, f of x is mod x, which is x dx. So this is 2 by pi, this is x square by 2, 0 to pi. So I am getting this value to be 2 by pi into pi square by 2, rest of the element 0. So this get cancelled. So we have a0 as pi. Simple. So a0 as pi. Now let us find out this bn. So what is this bn? Okay, so this, an. So this an is 2 by pi integration 0 to pi x into cos nx dx. Simple. Now you can apply the integration by parts over here. So we can find it in one line only. So what is an? an is equal to 2 by pi. Now apply integration by parts to this. So it should be x into integration of cos is sine nx by n, right? Yeah, sine nx by n, minus derivative of this 1 into derivative of this sine is minus cos nx, already n is there and again n, so this is n square 0 to pi. Simple. Now this is 2 by pi, in place of x you put pi, so sine pi is 0, sine 0 is 0, so this is 0 minus 0 minus minus plus 1 by n square, this is cos n pi minus cos 0. Okay, so this is nothing but 2 by pi n square, cos n pi is minus 1 to the power n, cos 0 is 1. This is my an. An is 2 by pi n square minus 1 to the power n minus 1. So after getting this a0, this and a and this, you just put these values in equation number a. So you can write equation a implies f of x is equal to a0. What is a0? Pi. So this is pi by 2. What is an? What is an? Just we have found out. An is this 2 by pi n square into minus 1 to the power n minus 1. Simple. Okay, now what you need to do? We have found out the Fourier series. We have expressed this function. What is my f of x? Mod x, or you can write x, mod x, whatever you want to write. Now this is just the first result that we wanted to find. Now you have to find out what the second result, and second result says hence deduce this is equal to pi square by 8. Okay, so see how we are going to do this. Here it is cos nx. Okay, so as you can see in the result that we have to prove, there is no term of cos, so we have to make this term as 1, and this can be made 1 by putting x is equal to 0. We can write put x is equal to 0, we get, the moment we put x is equal to 0, we'll be getting mod of x, mod of 0, which is 0. So this is 0 pi by 2 plus this is summation n is equal to 1 to infinity. You can take this 2 by pi outside because summation is on n, not on this. So this is 1 by n square minus 1 to the power n minus 1 into cos 0. Cos 0 is 1, so no need to write. Now you can just take this term to the left. So this is minus pi by 2 is equal to 2 by pi. Now put n is equal to 1. So when you put n is equal to 1, you will be getting 1 upon 1 square minus 1 minus 1 minus 2. Okay, now put n is equal to 2, so this is 0. So this is 1 upon 2 square into 0 plus put n is equal to 3, so this is 1 upon 3 square into minus 2. Put n is equal to 4, so this is 1 upon 4 square into 0 plus 1 upon 5 square into minus 2 plus and so on. Okay, so you can take this term to here. So this is minus pi square by 4. Here minus 2 is common throughout, is equal to minus 2 is common, so we remain with 1 upon 1 square, 1 upon 3 square, 1 upon 5 square plus and so on. So this minus minus become plus. So this minus minus become plus and we remain with, let me write down one step, pi square by 8 is equal to 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on. That is this. Hence the result. Okay. So I hope this problem that we have taken is clear to you, and you might have find this problem to be rather very easy as compared to the problem that we have taken in the earlier classes. So thank you for watching this learning video. Keep learning and keep supporting. Thank you.